Okay, so here we are with setting up the long division for this one because the degree of the numerator is greater than the degree of the denominator. So how does that work? So we're going to put an x here, and we're going to have x cubed plus x. At least the divisions they're giving you are pretty easy, right? Remember, you're subtracting all that, so we have negative x plus 1. So then the negative x plus 1 goes over the x squared plus 1. So I can't just put minus x plus 1 because then the 1 will be negative, so I have to put plus negative x plus 1. Or I thought about writing 1 minus x, but let's at least keep it in descending order. So that's our division. So hopefully you got that. All right, so now our integral of x cubed plus 1 over x squared plus 1 dx is equal to the integral of x plus negative x plus 1 over x squared plus 1 dx. All right, so I clearly can do the x separately. So one of the things we're doing is we're doing parts of this integral at a time. So I can do the integral of x and just get that out of the way as long as I keep the integral sign for the rest of it, negative x plus 1 over x squared plus 1 dx. So now what am I going to do? The denominator does not factor, right? Because it's x squared plus 1. We can't factor it. I mean, you could do x plus I, x minus I, but we're not doing that. All right. If I try to do u and du, I would have u equals x squared plus 1 and du equals 2x dx. I can make this, with 1/2 du equals x dx, but I can't get that plus 1 in there. I could even get the minus and minus, make the minus match. But that's all multiplying and dividing. What I can't do is add to this dx. I can't add the plus 1. So this is a fail. Does not work. But it was worth looking at. All right, so here's what we're going to do. This is a little bit different. Now, this is the only problem in which this happens, but it's foreshadowing. Keep an eye on it because this is going to come back on us. But it's not going to show up in your homework. All right, so what I'm going to do is I'm going to split this into two fractions, because remember, you have a plus or minus sign in the numerator. You can always split that out. So I think I'm actually going to pull the negative out, so I didn't need to write that plus there. Integral of x over x squared plus 1 dx. And then I'm going to separate out the 1 part, which is positive, so it's going to be plus the integral of 1 over x squared plus 1 dx. So I separated it into two integrals because they're going to require two different techniques. So because now I can see that this one, I can use u and du. I shouldn't have written that there because I'm going to put my u and du right here. I can use u equals x squared plus 1, du equals 2x dx. I have x dx, so 1/2 du equals x dx. So I can use that for this integral, but I can't use it for that integral. What am I going to do with that integral? That's the question. All right, well, let's see what we got here so far anyway, x squared over 2. So this is going to allow us to put minus, we'll put the 1/2 outside, and then I can just do u over it's du over u, du over u. All right, did you figure out what to do with this one yet? Remember how the derivative of inverse tangent is equal to 1 over 1 plus x squared? Do you remember that? Well, it is. That's what you use here. The antiderivative of 1 over x squared plus 1 is equal to inverse tangent x. All right, so this is one that's going to come up a lot. It's going to be, in the next couple of days, this is going to be an important technique to know that the antiderivative of 1 over x squared plus 1 is inverse tangent of x because the derivative of inverse tangent is 1 over 1 plus x squared. That's in your colossal compendium. I have not put the plus c yet because I still have an integral to do. So sorry about the mess there. Minus 1/2 ln absolute value of u plus inverse tangent x. Now I've done all my antiderivatives, so now I put the plus c. And I also sub back my u. So minus 1/2 ln absolute value of what was u? I can't even remember. It's a good thing I wrote it down. X squared plus 1 plus inverse tangent x plus c. This is the kind of crazy stuff that we're headed toward now. The kind of thing that tends to come up when you do the antiderivative of a rational function such as this one. All right, so I just want to do one more example because it occurred to me. We don't have a whole lot of examples. Like what would you do if this was x squared plus 5? Could we do that? I wonder. Let's find out.